How does space debris affect LEO satellites? Imagine a busy highway where tiny cars zip past each other at incredible speeds. Now picture that highway in space, specifically in low Earth orbit, or LEO, which extends up to 2,000 kilometers above Earth. This is where most of our communication, weather, and navigation satellites operate. But just like traffic jams and accidents on the road, space debris can cause serious problems for satellites up there. Space debris includes old satellite parts, spent rocket stages, and fragments from previous collisions. These pieces can be as small as a pinhead or as large as a broken satellite. Even tiny fragments can be dangerous because satellites in LEO travel at about 7.5 kilometers per second, over 17,000 miles per hour. That's faster than a bullet. At these speeds, even a small piece of debris can punch a hole in a satellite or disable it completely. When debris hits a satellite, it can cause damage that might lead to the satellite losing its ability to work. Sometimes, satellites need to perform quick maneuvers to avoid debris, which uses up fuel and shortens their lifespan. This makes it harder for satellite operators to keep their satellites functioning properly over time. There's also a bigger problem called the Kessler Syndrome. When debris crashes into a satellite, it creates even more fragments. These fragments then collide with other objects, creating a chain reaction. This cascade can fill certain regions of space with so much debris that it becomes nearly impossible to operate satellites safely. It's like a traffic pileup that keeps getting worse. The growing amount of debris also threatens human spaceflight missions. The International Space Station, which orbits at about 270 kilometers above Earth, could be hit by debris. While shielding helps protect astronauts, high-speed impacts from even small particles can be dangerous. This makes planning space missions more complicated and costly. Another issue is that as debris accumulates, some orbits become so crowded that launching new satellites becomes risky. For example, around 800 kilometers altitude, debris outnumbers active satellites by a large margin. This limits where new satellites can go and raises costs for space companies. Many pieces of debris stay in orbit for decades or even hundreds of years because there's little atmospheric drag at higher altitudes. Without active removal, this debris keeps piling up, making space less safe for everyone. Plus, the increase in satellites and debris can brighten the night sky, interfering with telescopes and astronomical research. To address these challenges, scientists and space agencies are working on ways to track debris better. Satellites can perform avoidance maneuvers if they detect a collision risk. International rules encourage responsible behavior, like deorbiting old satellites and removing leftover fuel to prevent explosions. Some groups are even developing technology to grab or destroy large debris pieces before they break apart further. In the end, space debris impacts LEO satellites by increasing the chances of collisions, damaging or destroying satellites, and making space less safe for future activities. Managing this debris is vital to keeping our satellite systems working smoothly and ensuring space remains accessible for years to come.